Well, let us discuss the attenuated wave and skin depth. Now, if you recall to our earlier discussions in electromagnetism, that is the electromagnetic wave equations in charge-free conducting mediums. How do we write the electromagnetic wave equations there? That in terms of E and B, we write the second-order differential equations like grad square E minus 1 by c square del square E by del t square, which equal to mu times sigma del E by del t. And similarly, for B, that is grad square B minus 1 by c square del square B by del t square, which equal to mu times sigma del B by del t. These two equations are the electromagnetic wave equation in charge-free conducting medium that we have seen. Now, if you see to the right hand terms in these two equations, that is mu times sigma del E by del t, and in the second, that is mu times sigma del B by del t, these two terms are called the dissipative terms, analogous to damping terms. As we have seen the damping terms, that is twice beta dx by dt when we are discussing the damped harmonic motions. So this twice beta dx by dt is analogous to these two terms in the right hand side of the electromagnetic wave equation in charge-free conducting medium. And these two terms are called dissipative terms, and these two terms in fact responsible for decay of energy and field of the electromagnetic waves. And that is why when the electromagnetic wave is advancing in a medium, of course in a conducting medium, the wave is getting attenuated. That means the amplitude as well as the intensity is decreasing. It is slowly the amplitude of the electromagnetic wave is falling, and the E vector and B vector is reducing continuously, of course sinusoidally, as is shown in the picture. So therefore, the attenuated wave are the dissipated electromagnetic wave due to its frequency and conducting medium. The frequency of the electromagnetic wave and the conductivity of the medium is responsible for this loss of energy of the electromagnetic waves. In fact, it holds, the conservation of energy holds good, because if you allow the electromagnetic waves continuously, the medium is getting heated up. And one of our beautiful experiment, in a raw experiment we can show our palm to sunlight, where after some time our palm getting heated up by getting continuous sunlight. It is an example of conservation of energy where the electromagnetic wave energy is transferred to our palm, and that is the reason why our palm is getting heated up. More importantly, when we discuss the attenuated waves, attenuated means now we know the electromagnetic wave is losing its energy continuously, and the wave is getting lesser intense, lesser energy in as time passes. And the decay of energy and fields, more importantly, are proportional to exponentially square root within bracket omega mu sigma by 2 times d, where d is the skin depth and omega obviously the frequency of electromagnetic wave, mu is the magnetic permeability of the conducting medium through which the electromagnetic wave is advancing, and sigma is conductivity of the medium in which the electromagnetic wave is advancing. So obviously now if you see, the electromagnetic wave has a frequency dependence on medium, and that is the reason why the electromagnetic wave is opaque for some mediums and transparent for some other mediums. So this is a frequency dependence of the electromagnetic waves. And coming to the skin depth, now what is skin depth? We can define the skin depth that the distance in which the field vectors, electric field and magnetic field vector of the electromagnetic wave which is advancing in a conducting medium reduces to 1/8 of its original value. Whatever original electric field and magnetic field it possesses, it reduces to 1/8 of its original value. So accordingly, d we can define, d in the skin depth we can define equal to square root within 2 upon omega sigma mu. So obviously the skin depth is now inversely proportional to square root of frequency of the electromagnetic wave. It is also, the skin depth is also inversely proportional to square root of magnetic permeability of the medium through which the electromagnetic wave is advancing. And again, this skin depth is also inversely proportional to square root of conductivity of the medium. So very often we get questions relating to, of course, in mostly in competitive examinations like objective types, we get how the relations are proportional. You must be very careful in minding that it is inversely proportional and square. Now, again, if you see to the cases of current flow in conductors, that current is a surface phenomenon, so it is now getting a confusion. But we can check up in one of the problem that for copper at a frequency of 100 Hertz, the skin depth is very marginal. It's very small. That means if you pick up the copper, that is conductivity of copper being 5.8 into 10 to the power 7, of course SI units, and magnetic permeability of the copper at a frequency of 100 Hertz, you can have nearly 0.99, that is SI unit. And if you substitute these three values, that is omega equal to 100 and sigma copper and mu copper, the skin depth will come nearly equal to 1.86 into 10 to the power minus 5 centimeter, which is very exceedingly small. So therefore, if you pick up a conductors, the depth to which the electromagnetic wave will penetrate is very small. That is why current is generally a surface phenomenon, as because the penetration depth is exceedingly small. Of course, the skin depth we frequently use as the term penetration depth. We will discuss more about this and related problems in our subsequent class. Thank you.